Okay, welcome back. So, what we're going to talk about now and work with is Galilean relativity. And this is what we get when we take a look at your frame of reference and how looking at the same effects, the same motion, for instance, appears in one frame of reference, one coordinate frame, compared to another. In particular, we're going to be looking at how things look when you have one coordinate system moving with some set velocity relative to another. So let's take a look at how that might go. So let's give an example of what we mean by this first. If we have, let's say, a school bus, and on the school bus, you have a bunch of kids in the bus, and maybe you're a kid in the bus, and you hop on, and while you're on the bus, you move with a velocity, of u relative to the bus. Of minus 1 meter per second. We're going to say that over to the right side of the board is the positive direction. So these subscripts here, the first subscript I'm using to indicate who's got the velocity, and the second subscript is what is being measured with respect to. So this person's velocity compared to the bus is -1 meter per second, where the bus is considered to be stationary as far as that measurement goes. This is what it might feel like while you're moving in the bus, whether the bus is at rest or the bus is itself moving compared to other things. You're usually judging your motion relative to the interior of that vehicle if you're moving inside a vehicle, which isn't recommended while it's moving, but it happens. Meanwhile, let's say that you have somebody else waiting for the bus, by some bus stop, and so they're hanging out and they see things as they move relative to the road. And relative to the road, they will see the bus moving. And this is some residential area, so the bus isn't moving super fast, but let's say that the motion of the bus relative to the road is 10 meters per second in the positive direction. And so we want to know, all right, well, if this person by the side of the road who is at rest relative to the road, motionless in the road's frame of reference, what velocity do they observe the person in the bus moving relative to the road? Velocity of, let's say, u relative to the road is what? And you can look at this, and perhaps you're doing it in your head and may have done it in your head already. These motions add together. If you're going backward within the bus, but it's going forward, then you're going to wind up going at a slower speed compared to the road than the bus itself. These motions are adding together. The 10 meters per second and the 1 meter per second, the -1 meter per second, are adding. And so it's the velocity of u with respect to the bus plus the velocity of the bus with respect to the road. So that's the sort of thing that we have with Galilean relativity. Relative to the road, you're moving at one velocity. Relative to the bus, you're moving at another. These are different frames of reference. And if you were to turn around and walk back in the other direction, maybe the bus is slowed down to 5 meters per second. You're called forward by the driver, and now you're moving with a little more speed at positive 2 meters per second. Then the calculation differs. The structure is the same. Your velocity relative to the road is your velocity relative to the bus, plus the bus's velocity relative to the road. Only now it's 2 meters per second plus 5 for a total of 7 meters per second in the positive direction. Now, as seen from the road, it looks like you're moving faster than the bus, as seen from the road. So we'll write this down as a general rule expressed more generally. That is that the velocity of object A with respect to object C is equal to the velocity of object A with respect to object B plus the velocity of object B with respect to object C. You add those motions together, and you get the motion in the other frame of reference. There's some other things we can see here. Let's imagine that you're driving the bus or you're driving a car. And let's say that you are traveling with a velocity of 65 miles per hour due north. What's that relative to? That's the velocity of the car relative to the road. But while you're sitting in the car, it doesn't necessarily feel like you're the one doing the moving. You see the world rushing back towards you. You see the world coming towards you, moving southward, while you're sitting in a comfortable chair or couch with your luxurious stereo, perhaps, and the world is moving around you in this way. You're stationary in your own frame of reference. So the velocity of the road relative to you is negative the velocity of you with respect to the road. It looks like the road and the world itself is moving 65 miles an hour south. I would call this the frame of reference where the person is stationary. I call this the egotistical frame of reference, where the universe revolves around them. So let's express those ideas in a couple of more equations. We can say that the velocity of A relative to B is equal to negative the velocity of B relative to A. And the velocity of A relative to itself is 0. You don't move compared to yourself. Cars don't move with respect to themselves. Unless there's something really disastrous going on, I'm not sure. Anyway, so that's our structure. And we'll do another video with some problem solving with this. We can see that I'm expressing these in terms of vectors, and the examples I gave were only in terms of one dimension. But these are vector quantities, and it applies for 2 dimensions, 3 dimensions as well.